Hey guys, I'm glad you got to this video first. This is part one of three videos on how you can use partial fractions to help with integration. So I'm going to show you in this video something we call partial fraction decomposition. And it starts with a general rational function, or rational expression, something like x minus 13 divided by 2x squared minus 7x plus 3. The key thing that we're looking for here is a way to break that singular complex fraction down into several fractions, maybe just two, but several fractions that have a linear, like mx plus b denominator. So anything like x squared we would deal with, and maybe another video will show you how to do that. Maybe it's part two. So step one is to understand that the denominator, what it is and how do you factor it. And I have a quadratic. I have 2x squared minus 7x plus 3. So using the AC method, factors of 2 times 3, that then add to negative 7. That'll allow us to break apart the negative 7x into two terms, two binomials, I mean. And no, that's right, I said two terms. And then therefore we have groups of two binomials that we can then factor and find common things. So therefore, 2x squared minus 7x plus 3 factors into x minus 3 times quantity 2x minus 1. Those become the new denominators. We don't know what a is. We don't know what b is. I mean, in that I need something to be the numerator. And the truth is that a over x divided by x minus 3 and plus b over 2x minus 1 together, they still need to equal x minus 13. So there still needs to be this way to bring them back together, and the answer should still be what it was when we originally started. The step that I use right here is I noticed that if I want to say that I'm going to actually kind of break apart but combine them back together, a is missing the 2x minus 1 factor so that there's a common denominator. B is missing the x minus 3 factor so that there's a common denominator. And after we do that part, we can now write it all as this expression that's all over the original denominator, 2x squared, yada yada. Distributing and some clever regrouping means that we're going to have x's 2a plus b. Those are both multiplied by x, so we're going to factor x out. And then the rest that doesn't have x next to it, negative a minus 3b, those are going to get grouped together because technically 2a plus b should equal 1 in that it's the number that is multiplying x. Furthermore, the subtraction, take out the minus sign, we have a plus 3b, that should equal 13 because it's the constant. It doesn't have an x component next to it. So I'm going to write it out, and I'm going to solve a system of equations. Again, the goal here is to go back and have that one larger expression be broken up into two smaller ones, two fractions that have linear denominators. So 2a plus b should equal 1 because 1 is the coefficient of 1x minus 3. 13. And then a plus 3b should equal 13. So we have a system of equations. We got to figure out what a and b are, and then they can go back in. You could graph it, find out where they cross. You could use the substitution method where you solve one, move it over. You could use elimination, which is what I use. There is this thing called RREFing, which linear algebra, when you get there, it makes this whole why didn't we learn this conversation so much better. I like elimination in this problem because I notice a is just half of 2a. So if I double it and make it negative, I can just combine straight down the columns, like 2a minus a, 0. 3 times negative 2. b minus 6b gives me negative 5b. And ultimately, I get the top of that b fraction. It's 5 over 2x minus 1. Plug that back in, and I get that a equals, what was it, negative 2. That's going to go over the other denominator. So this is a way for us to get ready to integrate when we've exhausted substitution, we've exhausted integration by parts, we've exhausted maybe just go to the calculator because we just got to get some answer. And if we can rewrite the rational expression as two fractions that we add together, like these linear ones, it's going to be able for us to just integrate easily. There is part 2 and part 3 coming where I work through some of these antiderivative problems. So thanks for watching the video. Thanks for giving it a chance, doing some math with me. And yeah, be sure to check out the second and third ones. Give them a couple of once-overs because they're going to take some time. Thanks for doing this math with me. Catch you in the next video.